Hello everyone, in this tutorial we are going to create the autopilot system for our aircraft. This autopilot system will control the roll, pitch and yaw to turn to the direction, the target direction and the target altitude. First we go to testing site, and when we play and run this, we can see the wing trail is very bright because we set it to the missile is very large, so we need to adjust it for this testing site. Press 1 and click. This set to 0.5. Apply and save. Next we create blueprint, actor component. This name is aircraft AI component because autopilot is some type of AI that control the aircraft. Next we can create the variable. Target location, vector, HKP, float, your KP, roll KP, to target, vector, desired direction, pitch error, float, your error, pitch rate, your rate, roll rate, base, HKP, KD, base, your KD, base, roll, KD, lateral plane, lateral damping scale, make deflection in radian, pitch plane, aircraft. This type is BP airplane. Autopilot. This is Boolean. Auto pitch input, float, auto yaw input, float, auto roll input, target direction. This is vector. Target altitude. Float. Next, we can set the value R. We have a little bit of different layout, so we load the correct layout. This HKP is 2. Your KP 1.5 and roll KP is 2. And next, the target altitude is 10,000. In begin play, we get owner has to BP airplane, and we set it to this variable aircraft. Next, we set max deflection radian, so we want to have 20 degree to radian, and this is 20. In event tick, we get the aircraft. Check if it's valid. Get autopilot. If it's true, then we set the target location. So get aircraft and get vector location. Add it with the target direction. Get target direction. Multiply by forward value 10,000. Then add with this and break the vector. Make vector X and Y. Z is target altitude and connect to this target location. Then we can draw debug sphere. And set radius to 50. Choose green color. Duration 0 and thickness is 5 because we draw in event tick, so we set it to 0. Next, we create a custom event. Name it update control surfaces, and we call this in event tick update control surfaces. If we change this target direction to get this aircraft forward direction, forward vector, actor forward vector, and when we play this, we will see the draw debug sphere. Let's set this autopilot to true. We need to add this component to BP aircraft AI component and play. We can see this target location at 100 meter altitude, the green dark sphere. So our target location is working. To this aircraft AI component and connect this target direction back. Get autopilot. We update only when autopilot is true. And aircraft and is valid. Create a sequence. Then we get target location. Track with aircraft location. This is to target vector. This to target, we normalize it. And desired direction. This desired direction we do the dot product with aircraft actor app vector a 10 to radian. And this desired direction dot product with forward vector of the actor. This we get the pitch error. Degree, which is the radian. We can copy this and this desired direction with dot product with right vector actor vector. And now we get the yaw error. So the error we have the pitch and yaw. Next we need to get the pitch rate yaw rate and roll rate. Get aircraft, get aircraft mesh, get physics, angular velocity in radian. And we dot product, get aircraft, get actor right vector, and we dot product with this. This is the pitch rate. That pitch rate. And we copy this. Get aircraft. Get actor up. Up vector. And this is the yaw rate. And do the same. Get aircraft. Get actor forward vector. And this is the roll rate. Next, we need to set the page KD, base page KD, by using the value from page KP. Get page KP or square root multiply by 0.5. Do the same for base your KD. We can copy this. Use your KP. And base roll KD. Copy. This is roll KP. Now we need to create a function to calculate the pitch blend. Calculate pitch blend. We add local variable, vertical error, and this is float. We want our aircraft to reduce the sensitivity of the control when it is near the target location. So it didn't oscillate. Vertical make distance. When we compare this vertical make distance set to 100. To target, and we use only z value called absolute. This is vertical error. get this vertical error, divide it with vertical make distance, clamp, float from 0 to 1, and we set it to pitch blend. We find this variable, this one, pitch blend. Get pitch blend. And linear interpolate love between 0 to 1. Love between 2 to 0.1. We reuse the control sensitivity from 2 to 0.1. We don't have this variable, so we add this variable. Pitch damping scale. Set to pitch damping scale. Next, we calculate pitch command. Calculate, create a function, calculate pitch command, CMD. Then add variable. Local variable is pitch CMD. Create a sequence. Then set pitch CMD, this local variable, to calculate the pitch command. We need to have pitch KP multiplied with pitch error subtract with base pitch KD, pitch rate. We multiply this and multiply with pitch damping scale, and we subtract with this. Then this pitch command value, we clamp it, clamp float minus 0.5 to 0.5. We don't want it to be the strong value because it will be unrealistic. Multiply with -1 to flip it. Then set this back to pitch command. Next, we get pitch CMD multiply with pitch blend. Get pitch blend. And set back to pitch CMD. And we call return. This pitch CMD next with return node. Name this to pitch and compile. Next, we calculate the lateral plane. Calculate lateral plane. We get these two targets. Dot product. Get aircraft. Get actor, right vector. And absolute. Set lateral error. We need to add local variable lateral error. And another variable is lateral make distance. This compile and this lateral make distance set to 100, the same as vertical make distance. We set this lateral error. Next, we divide this lateral error by the lateral make distance. So the lateral is working in the x and y axis. For the vertical, it works on the z axis. We clamp float from 0 to 1. This is lateral plane. Get lateral plane. And we do the loop from 1 to 0.1. This we set lateral damping scale. And go to event graph. We add the function calculate your CMD. And to calculate this yaw, we need yaw KP, the same as calculate the pitch. We need yaw error, then subtract with base yaw KD. Get yaw rate. Lateral damping scale. Multiply this. We need to add local variable, name your CMD. This your CMD. We claim this float minus 0.1 to 0.1. We don't want too much yaw control, so we set your CMD and multiply this with lateral plane. We call return output yaw, and this is float. Compile. Next, we calculate the roll. Calculate roll CMD. We need to add some local variable. Current roll degree. Target roll degree. Roll error rate radian. Roll CMD. We use this current and target roll degree because we want to limit the angle of our aircraft that when we roll. Get aircraft, get vertical rotation from aircraft mesh. Then brake rotator, the roll, normalize axis. Then we set to current roll degree. Get yaw error. We use yaw error to create the roll. Radian to degree. Multiply by 2. And set to target roll degree. This target roll degree we clamp float. Min is minus 45, max is 45. Set target roll degree. And this is a sequence. We set roll error radian. By get target roll degree, subtract with current roll degree, and degree to radian to this. And we get roll KP multiply by roll error radian subtract with base roll KD, and this we multiply with roll rate and lateral damping scale. We set roll CMD. Next, we clamp this roll CMD. Clamp float minus 0.3 and max is 0.3. We set this roll CMD. This roll CMD we multiply with lateral plane. And last, we return output roll. We return this roll CMD and save. In event graph, add pin, we create a sequence after this. So we call the function calculate pick blend. To blend the distance of the pitch. Then we calculate pick CMD. And this CMD we multiply with max deflection radian. Then we can set this as the input. Auto pitch input from Autopilot system. Next, we calculate lateral plane. Calculate your CMD. Multiply with max deflection radian. And we set to auto your input. And we calculate the roll CMD. Multiply with max deflection radian. Set auto roll input. Create a custom event. Name it set aircraft input. And we call this set aircraft input. Create a sequence. In the BP airplane, we need to have the variable when we call this input action. So roll, pitch, and yaw. So we get aircraft. get role, add a branch. When it fall, we set the aircraft input, set role input with the autopilot. And we get page. This aircraft, set page input. This we need to role input, set role input, not page. Get auto role input. And this one is page. And next is yaw. Add a branch. Get aircraft. Set yaw input. Get auto yaw input. Create a custom event. Name it. Set target direction. And this is angle. Add with 90. Make rotator. This is yaw. Add rotation x vector. And set target location, target direction. Add another custom event. Name it. Set target altitude. This is float input altitude. Just set to this target altitude. So now we can go to this VP airplane. We can delete camera rotation variable because we don't use it. Add variable boolean autopilot. And this widget, we only create the widget when it is player. Example, now if we add another BP airplane, we going to have two widgets on top of each other. So you can see this widget. So we want to create it only on player. Move this. is player control. Okay, add a branch. If it's true, we create this widget. So now when we play, we can see we have only one widget for the player process widget. In this event tick, we move this Niagara trail to this instead. We want this Niagara trail to work with the autopilot system too. So we move it to event tick. Now this role, let's make some room for this. This role, and it's true. And when complete, set role to false. And connect to branch. Get autopilot and this branch. This when it fall. When it's true, we check if the input is 0. When it fall, we set roll input. This is roll input. Do the same with the pitch. Set pitch is true and pitch is false. When complete, and get autopilot. When it's false, pitch true, pitch false. Next we add a branch. Check if this value is 0. When it's false, we set this pitch input. And this yaw, set yaw to true. And set yaw to false. And complete. Get autopilot. Add branch. When it falls, that is your input. And when it's true, we check if it is not 0. and we set this your input. We adjust this because we want to override the player input. When we set the autopilot and we have the player input, we will override the input for the player to control instead of autopilot. We can go to the widget and we go to graph, add variable, autopilot, boolean. And this we need a custom event. Name it autopilot. Get autopilot variable or not boolean and set autopilot. We opposite this value. Get this aircraft AI component. Set autopilot. We still don't have this event. Go to aircraft AI component. Create custom event or set autopilot. Input is boolean and it is autopilot. Set to this variable. To VP airplane, set autopilot. This is the boolean and we have the widget. Set the boolean autopilot. Now we go to input. We duplicate IA brake and rename it to IA autopilot. This is boolean. Go to IMC, add another mapping, IA autopilot, and this is the when we press it, we activate the autopilot. So IA autopilot is event. Do one trigger and complete reset. When complete, set autopilot. Go to this VP AI component. Set this to false. The default value is false. Display. We can move this found location to up this and delete the aircraft. VP airplane. Reduce the line trace. Let's see. This line trace. set it to 1500. And when play, we have this airplane flying from start. So set it to higher location. We can go to this target direction and set y axis to 1, the default value. And when we play, set and return a little bit and press Z. Now our autopilot system will take control of the aircraft and fly to Y direction. And the altitude is 100. And we can steer control by using the player controller. And when we press Z again, we disable the autopilot. Next, we need to adjust some of our widgets. Go to designer and we add the instruction. Duplicate this. This is autopilot Z. Can move this down. Change this padding row. And we will add another this is mouse cursor. When we press tab, and we can adjust this border. Save this. Next, we can add another canvas panel. Add vertical box. Add border. And add text. Let's write this text. This is autopilot off. And we change the appearance. This color is 0.5. And we change font from bold to regular. Go to border, vertical box. The size is 300. Y is 128. And the canvas panel anchor. This is the right. Move this anchor position X minus 351. And this is 50 for Y. Size to content. And we need to change the border color. We want it to fill the same color as this. This border color 0.1. As color 0.1. And change to auto. And then we can go to the graph and add this pin, Autopilot, add a branch. So the text we need to enable this 92, text block 92, set text. When it's true, Autopilot is on, and when it falls, it is off. And we need to change the color of this text block. Set color and opacity. And make the slate color this is white. And when it falls, we don't want it to be we want the opacity to be 0.5. Okay. Then we set brush color of the border. This border is variable, and set brush color make color this is green 0.3. And white 0.1. And save. And when we play this, we can see the autopilot. Press Z. We change it to green and autopilot is on. Press Z again, it is off. Next, we want to enable mouse cursor. When we press tab, so duplicate and this autopilot, rename it IA mouse cursor. Add it to IMC default. This is mouse cursor, and this is tab. Go to BP, a plane, call IA, mouse cursor, do one, trigger, complete, get mouse cursor, add variable, this is mouse cursor boolean, not boolean, if it's true, we get player controller, set input mode, game and UI, and then we set the cursor, set mouse cursor, so mouse cursor is true. When it's false, call set input mode, game only. Or set so mouse cursor is false. And we compile this. Let's play. When we press tab, we see this mouse cursor. Tab again behind this mouse cursor. Next, go to this widget. And we add the horizontal box to this vertical box. And this is text. Next is text box. Inside this horizontal box. And this text we can write to target dir for direction. Space. Change the color opacity to 0.5. And the font to regular. And we need to change this text box. This text box color, background 0.1. Copy this. All the background image, focus, foreground. Foreground, we don't need to change it. We change the text style. This color we don't inherit. We change it to white color. And this horizontal box is set to this box set to field, and we compile. Let's test this and press tab. We click on this and we can type on this direction, target direction. Next, we can duplicate this horizontal box. Control C, Control V. This is altitude target L, ALT. Go to graph. Create a custom event. Name it set target direction display. And input is load angle. We need to set this to variable. Editable text box. Set text. String first. Convert this angle to string. Append with degree. And search for degree symbol. We copy from Google. To text. Then we set it to this. Create a custom event. Name it to set altitude display. And this is input altitude. Load to text. This is the input is variable. Set text. This is the text of the altitude. Next is editable text box. We need to apply the value on text commit when we enter. So we get BP, airplane, aircraft, AI component, for set target direction. And we convert this text to string. String we convert to float. And this float to angle. And we call set the display to append with this degree symbol. Set target direction display. And this one, we commit this. Set target altitude, full string, full float, this altitude we set altitude display. And this to text we use float to text function. Because this we can disable the grouping. The same with this angle, float to text. This angle we change string to text. And compile. Go to BP airplane. And when we begin play, go to aircraft AI component, create a custom event, name it update target autopilot. We get aircraft, get widget is valid, get aircraft, get widget, and set target direction display. This we get target direction, make rotation from X, did this is your angle, and this widget, set altitude display, and this is target altitude. We can rename this to set target altitude display. Now go to BP airplane. In begin play, after we create the widget, we need to update the widget. So call aircraft AI component, update target autopilot. Now let's play. You can see the target direction is 90 and altitude is 10,000. When we start, let's press Z, start, and this is 90 degree. We press tab to see the mouse cursor, and now we change to 0 degree, enter, but it didn't work. Let's set the target direction to 0, Victor, and play. The target direction is 0. Press Z. When we start, we go to aircraft AI component and we subtract this with 90 and the target direction we set Y to 1. So let's play test and press Z. Now we have the correct target direction when we start, and we can change this. Press tab to see the mouse cursor and we change this to 90 degree. Enter. We turn right. And we change the altitude to 5,000, 50,000. It fly up. Go to WB Widget Designer. We can add the button. To this vertical box and move this and move the border inside the button. And this button, we can change the color, background color to 0, alpha. And we set its variable for the button. On click event. When we click the button, we want to set the autopilot to true. First, we get BP airplane, aircraft, AI component. Or set target, altitude. Save this first. And this editable box. We get text. And this text to string and to float. Next, we set target direction. And this text box. Get text to string to float. And we call set autopilot. BP airplane, set autopilot. We have incorrect editable box. This one is direction 256. And this one is altitude. compile and save. Press Z, and we can press tab and click on this to enable the autopilot. The same as press Z. Can set the direction minus 90 degree, turn left at 5000 altitude. This is the end of our tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.